Alright, so here's our project proposal for Team 1, and Team 1 is Hayden, Mabel, Cynthia, and I'm Ryan. So we had two main objectives for this project. The first one was to improve safety in public transportation, because we feel that public transportation safety can be improved in many large metropolitan cities. And then on average, about 63,000 buses of all kinds are involved in accidents each year, and then 14,000 of those result in an injured person, and 325 result in a fatal injury. The second objective we had for our project was to make the public transportation system environmentally friendly, because about 54% of public transportation buses still run on fossil fuels and non-renewable energy sources. And the public transportation industry currently accounts for about 24% of the world's total emissions produced, which is quite a lot. So for this project, we're going to try to go about reducing that number. For our customer concerns, public transportation safety is one of our main objectives, and it's also one of the main objectives of our target stakeholder, Mayor Jimmy Domino. Mayor Domino is also concerned with having an economically aware public transportation system. With the large number of tourists and overall population living in Sparkyville, it's easy to cause pollution and inefficient traffic systems, so that's some of the problems we're going to be looking at solving in this project. Why solar energy? A solar powered transportation system will produce far fewer emissions and go about helping Sparkyville's pollution problem, and it will also make it more environmentally friendly and provide a better overall atmosphere for the city with less pollution. An efficient solar powered transportation system may also be economically better for the city in the long run. For the safety features of our chosen design, a solar powered van, it's sturdy and it can also fit a good number of passengers, allowing us to have both customer safety and efficiency. The van was the most safe idea, as it can effectively carry a large number of passengers and luggage without endangering their safety. And then here were some of the design requirements we had while completing this project.
Alright, so before we can start designing our own solar powered car, we need to do some research on some of the options that we have. Now we know that solar energy is clean and renewable, but it is not the most reliable. So most solar powered cars have to have either a form of energy storage and or an alternative energy source. So basically there are two types of solar powered cars, electric and hybrid. An electric car has an electric motor and rechargeable batteries, while a hybrid car also has electric motors, but they have an internal combustion engine which runs on fuel like gasoline. Now to make our design, we can look at some of the current technology that is available on the market today. In 2010, Toyota came out with a Prius that had a solar panel that was flat on the roof. However, the energy output provided by the solar panel was only enough to power a fan. Now in 2014, Ford also came out with a design that increased the power output of their solar panel by concentrating the sun's rays using some special lenses. However, this still wasn't enough to power the entire car. But for the purpose of our design, we're only going to be focusing on the car running on solar energy and not on a battery. So for our experiments, we tested three different things: solar cell versus efficiency, angle versus power output, and motor versus speed. And what we found was that the dual blue solar panel was the most efficient. The angle that gave us the greatest power was 0 degrees, and the motor that was the fastest was the Mabuchi. So to make our design, we need to consider some basic scientific properties, such as gear ratio and circuit configuration. Basically, a high gear ratio would give us more torque and less speed, and a low gear ratio would give us more speed and less torque. Now for circuit configuration, we have a few different options: series or parallel. If we wired it in series, it would just be one continuous loop of electricity, and this allows us to increase the voltage but keep the current the same. If we wire in parallel, there are multiple paths for the electricity to take, which increases current but keeps the voltage the same. And another plus of wiring in parallel is if one part of the circuit breaks, the electricity still has somewhere else to run.
Okay, so for the justifications of design for our project, we started with an analytical hierarchy process chart. And so what this is we develop criteria based on the customer's wants and needs, and then we rank them against each other to find out which criteria is what our customers desire the most. And what we discovered is that safety is a common criteria across the board and what customers want to see most in this new car. And then after that, we came up with 3 brainstorming sketches, and the first sketch we came up with was a solar-powered truck. So the basics of this design is you have a truck base and frame with an adjustable solar roof on top. It can sit up to 4 different people and hold 2 pieces of luggage. Also, the back of the truck door acts as a handicap ramp, so you can load up someone with a wheelchair or put their wheelchair in the back. For our second sketch, we have a solar-powered van. So what this is just basically a van design with a solar panel on top. And it allows for safe storage of passengers, and it can hold up to 6 people, and it can store 2 pieces of luggage, and it has an adjustable solar roof. Then for our third sketch, it's another solar-powered van, but this one's a little bit different than the last. So what's key about this van is it can hold up to 6 different passengers, or it can hold 3 pieces of luggage and 5 passengers. So the way it works is you have a ramp on the back that you could load your luggage in, or a handicapped person up the ramp into your car. And if you want to fit an extra piece of luggage, you just take up one of the seats with the luggage. And then after that, we decided when we're going to evaluate our designs, the justifications would come based on real life examples and products that are already on market. So the first thing we looked at was safety. So we looked at existing cars like trucks and vans to see how safe they were and see which design is the safer of the two. And then we evaluated the wheelchair ramp effectiveness by looking at real cars and their wheelchair ramps and seeing how they work and which design would fully follow through with existing products. And then when we looked at solar powered cars, we looked at existing prototype cars that are out there to make sure the way we were planning on making the solar powered cars actually works, not just in theory, but in reality. And then once we did that, we came up with a decision matrix where we compared all 3 of our brainstorming sketches, and we analyzed them based on our criteria, and we found out which one met our criteria the most and would satisfy our customers' needs.
Our proposed design is sketch number 2. Sketch number 2 was a storage van with adjustable roof. The adjustable roof is the solar panel, which allows for maximum efficiency to gain power from the sunlight. The shape of the van is an elongated box, which allows for ample space for passengers and luggages. We estimate to be able to fit at least 6 people with 3 pieces of luggage. The vehicle is going to be ran with 2 motors, which are the Mabuchi motors, which are cheap yet efficient. The frame of the vehicle is going to be built with balsa wood, and in the front of the car is going to have a light sensor identifying green and red lights at intersections. This is a diagram of our vehicle, the front, top, and side view, each with only approximate dimensions because the group is not sure of exactly how big they want the vehicle. The materials. The group estimates about $53.90 for the whole construction of the vehicle. Everything is approximate and things may change due to certain needs, but as of right now, the approximate bill would be $53.90. The group predicts the speed to be 0.531 meters per second. What was needed to calculate this is the mass, the number of tires, force of friction, the radius of the tire, and the max power of the motor. The group wanted to satisfy all the customers, and as they went down, the group realized the mayor wants safety yet environmentally friendly. Due to this, the group enclosed the car to keep passengers safe, has seat belts, and runs on solar energy. To please Susan, they designed a wheelchair ramp in the back of the vehicle. To please the commissioner, the light sensor allows for the car to stop at red lights. To please the Hernandez family, the car is built to fit 6 people, which allows for large parties. And to please Jeffrey Douglas, in the back has extra space for suitcases and his golf clubs. In conclusion, the group says the design is a perfect solution to Sparkyville's problems because it runs well, is efficient, and pleases all the customers' demands. These are all the references used.